Welcome to AI Intuition Studio. Let's understand the logic, not just the code. In this video, we are going to break down machine learning definitions in a simple way. So, by the end, you don't just know definitions, you actually understand the concept. What is learning? Learning is about performance improvement over time. If a system is exposed to experience but its performance does not improve, then learning has not actually happened. Moving on, what is machine learning? Tom Mitchell, one of the pioneers in machine learning, gave one of the most practical definition of machine learning. He says that a machine learn if its performance P on a task T improve with experience A. This definition is powerful because it gives us a way to quantify learning. In machine learning, we don't tell computer what to do. We show it examples and the machine figures out how to do it on its own. If a machine improves its decision by seeing more data and without changing the code, that's machine learning. Now let's understand this definition P, T and E. What are they? Now let's take a real world example, YouTube. When you open a YouTube, its task is very clear. The system has to decide which video to recommend to you next. So a machine learning algorithm is running. This decision making is called the task T. But YouTube does not randomly recommend videos. It learns from your past behavior. The videos you watched, skipped, liked or disliked, how long you watched a video and what you searched for. All this past data is called experience, E. Now how does YouTube know it's doing a good job? Whether its algorithm, machine learning which is running is a good or not? It measures performance by checking things like, did you click the video? Did you watch it till the end? Did you stay longer on the platform? If these numbers improve, YouTube believes its recommendations are better. This improvement is measured as performance P. So if I have to conclude it, so when YouTube improve its recommendation T by learning from user behavior E and measures success using engagement performance P, it is following exactly what we call machine learning. Now moving on, let's see some example of machine learning. Learning to classify a new astronomical structure, categorize email into spam or legitimate, self-driving vehicles, Netflix recommendation. Netflix, for example, does not understand movie the way humans do. Netflix understand user behavior. What you watch, skip, pause or rewatch. Machine learning converts this behavior into personalized prediction. Similarly, self-driving cars do not rely on fixed driving rules. They learn from millions of driving experiences collected from real world data. Let's move on. Now, let's see how machine learning looks at a real world problem. Suppose we want to predict whether a student will receive a job offer or not. A machine cannot understand things like how much potential that student have, what talents it have, what skills it have. It can only work with information which can be quantified. So we break this problem into smaller quantitative parts. Academic performance, communication ability, logical thinking, and coding skills. Each of these information is called feature. In employability prediction, features such as CGPA, communication skill, aptitude, and programming skills are used. Now, what is the final decision we want the model to make? Yes or no? Job was offered or not? This final outcome is called target label. Notice something important here. There is no single feature that decide employability. Machine learning works by combining many weak signals to predict the target label. This idea, learning from features to predict a target, is the foundation of most predictive systems. Let's move on. Let's take another example. In this example, the task is different. We are not predicting a category. We are predicting a numerical value. Features such as brand, year of manufacture, mileage, distant travel all contribute partially to the final price. Machine learning learns how much weight or weightage, how much importance or weight to assign to each feature based on historical data. Okay. Now let's move on to another example. So now that we understand what is feature, what is target label, let's talk about the first major type of machine learning, that is supervised learning. In supervised learning, machine is trained using label data. That means for every input, we already know the correct output. Think of it like learning with teacher. Teacher shows example and also give the correct answer. For example, we provide student data like CGPA, communication skill, programming skill, and along with that data, we already know whether a job was offered or not. The model learns the relationship between feature and the target label. Because the correct answers are available during training, this approach is called supervised learning. Let's move on. Now let's understand unsupervised learning using a business example. Market segmentation. Imagine a company has data about thousands of customers, their age, income, location, spending habit, and purchase history. Notice something important here. The company does not know the customer type in advance. There is no label saying premium customer, budget customer, or occasional shopper. The machine is only given customer data with no predefined categories. Using this data, model automatically groups customers based on similar behavior and characteristics. One group may consist of high income, frequent buyer, another group may consist of price sensitive customers. These groups are not given by human, they are discovered by algorithm. This process of finding natural group in data without any label is called unsupervised learning. Let's move on. Now let's zoom in further and understand type of supervised learning. The first type is regression. Regression is used when the target value is continuous, meaning it can take any numerical value. For example, predicting a salary, predicting house price, or predicting marks. Here output is not yes or no, it is number. The model learns from past data and tries to estimate the most accurate numerical value. So whenever the question is how much, how many, we use regression. The second type of supervised learning is classification. Classification is used when the target label is categorical. That means the output belongs to a fixed set of classes. For example, job offered Yes or no, yes and no are classes. Email, spam or not spam, disease, present or not present. If we take a test, in our employability example, we predict we are predicting whether the student will receive a job offer or not. Since the output is yes or no, this problem is a classification problem. So whenever the question is which category does this belong to, we use classification. Here are few examples which I have taken, and you can tell whether it's a classification or regression. Predicting whether a patient has a particular disease or not. Definitely, it's a classification. Handwriting digit recognition. Classification. Email spam detection. Classification. Predicting house or property price. It's a regression because we are predicting a number. Predicting a stock market price. Predicting sales of product. Regression. So let me close by framing what we actually learned today. We didn't discuss algorithm, tools or libraries deliberately. What we focused on is the structure of machine learning problem. Every real ML system, regardless of scale or sophistication, starts by answering a few fundamental questions. What aspects of real world are we quantifying? Those become the features. What decisions or outcome are we optimizing for? That defines the target. Do we already know the correct outcome? Or we are discovering a structure that determines whether the problem is supervised or unsupervised? And finally, are we estimating a continuous value or a discrete class, which leads us to regression or classification? With this, I conclude my video. If this helped you understand